So a lot of people would think that it has something to do with the weight of the candle pieces, and maybe you answered that after the first experiment. You said, oh, the bigger piece sunk to the bottom, or the heavier piece sunk to the bottom because it's heavier than the lighter piece. But then when I went ahead and switched the candles, you now know that it has something to do with the liquid that it's going into. What we're studying here is a subject called density. This candle has the same density. It doesn't matter how large a piece of candle I have. If I take the largest candle I possibly can have and put it in this container, it's still going to float. And if I put it in this container, it's still going to sink. So what we want to do as scientists is measure the density of objects, because it lets us know whether things would float or sink in water or any fluid. If an object has a lower density than the fluid it's in, then it's going to float. And if an object has a higher density than the fluid is in, then it sinks. And the container to your left, this was water, and the container on the right, that was rubbing alcohol. Two different liquids with two different densities. Water's density is a simple one to remember. It's 1 gram per milliliter. So since the candle was floating in the water, that means that its density is less than 1 gram per milliliter. So this is somewhere less than 1 gram per milliliter. The rubbing alcohol then must have a density of its liquid which is less than the candle. Since the candle's density is more, it's going to sink down. It's exactly why you don't launch a ship at sea without knowing exactly what its density is. You don't take a chance as to whether it's going to float or sink. It doesn't matter if the material it's made of is really, really heavy, like a battleship could be thousands and thousands of tons. Yet they spread it out over a big area so that it displaces enough water that it can sit there and float. So to figure out an object's density, you need to know two things. What are its mass, the amount of stuff that it's made of, and its volume, the amount of space it takes up. Density is the amount of stuff in a given space. Imagine being inside a classroom with 3 people. You'd have a lot of room to move around. There's not many people in there. It's at a low density. But stick 300 people in the room that you're in. You're going to be stuffed together, up against each other. Not a lot of room to wiggle. That would be a high density. So before you launch a boat, or if you want to find out if an object's going to float or not, it's easy. Just calculate the mass of the object and divide it by its volume. So let's go ahead and do that right now. Let's calculate the density of 2 objects. 2 soft drinks, one of them regular, one of them diet, and we'll see what their density is. So there we have our balance for measuring mass, but we also need to know its volume, or how much space it takes up. And lucky for us, it's printed right here on the can. 355 milliliters. Now that's the amount of liquid that's inside. They don't tell you that there's 20 milliliters worth of metal in there. So on our formula here, we know that the density is going to equal some number divided by 375 milliliters. We have to figure out its mass, and that's what the balance is for. 385.21 grams. So that now goes in the top of our fraction, 385.21 grams. Then we divide that by 375, and that gives us a density of the regular soda at 1.02 grams per milliliter. Now remember, the density of tap water is right around 1 gram per milliliter. So if I put that can inside water, it should sink. Now we'll look at the diet soda, and it has the exact same volume as the regular soda. In fact, it's almost exactly the same. Let's measure its mass. It's 371.79 grams. So we put that in the top of the fraction, and then we divide that, and we have a density of 0.99 grams per milliliter. Now water's density is 1. So if we take the diet soda and put it in the water, it should float. First, the regular soda. It's upright, but it sank to the bottom. Now let's go ahead and try that with the diet soda. Sure enough, it floats. By the way, the only difference between the gray can and the red can, the same size, they have the exact same ingredients, but the gray can doesn't have sugar. It has another chemical instead. All the sugar's in here, which is what gives it more mass. In fact, it has it right here on the label. It says 39 grams of sugar that's dissolved partially into this soda. A lot of people can't visualize 39 grams, so I have that here in this beaker for you. It's basically a handful. If you can picture picking up a handful of sugar, that's how much is in a regular can of soda. A can of soda, which is 12 ounces. The bottles you buy in the store are 20 ounces. So that's 1.5 handfuls of sugar. So you can tell if something is going to float or sink just by doing a little math and studying the density of the object. And when I think about objects that float or sink, I think about something very historical, the Titanic. You know, ships are made of steel, and those steel beams don't float, but if you put them in the shape that takes up a lot of volume and a lot of air down in the hull, then it could float. Most ships, there's a lot under the water that you can't see. So the Titanic is a famous ship, and it was considered unsinkable because it had compartments below deck, where if there was a cut or there was a rupture in the hull, only a single compartment would fill up with water. The Titanic did sink, and it did so because it hit an iceberg at just the right angle that the breach in the hull took out more than one compartment. So here's a schematic of the Titanic, and you can see the compartments there. Now, 4 of them could fill up with water, and they knew that because they knew the mass of the ship. And the mass of the ship was such that its density was under 1 and it could stay afloat. However, if it took on water, it would be taking on mass. As you increase the mass, that's going to make the density rise. And they knew that 4 compartments could flood safely to keep the ship afloat. Unfortunately, 6 of them were breached. And the flooding starts in the front compartment. So the front one begins the flood. It takes on 190 tons of water, which dips it at an angle. And then the second one begins the flood. And then the third begins to flood. And now the Titanic's nose is going under the water. Those compartments are not sealed off from one another. So like an ice cube tray, if the water gets to the top of the compartment, it begins to spill over into the next one. At this point, it's taken on over 3,100 tons. Now the 4th compartment has started to flood and Titanic's in trouble. As it's starting to pitch down into the water further, now we're going to start flooding into the 5th and the 6th compartment, and this is when they knew that the ship was doomed and was going to wind up at the bottom of the Atlantic. Eventually, the back end sticks out of the water and the stress and strain on the ship breaks off the back half, and of course the rest is history. So in the end, it's important to remember that if an object has a lower density than the fluid, it floats. If an object has a higher density than the fluid it's in, it sinks. Now we're talking a lot about fluids, so what does this have to do with weather? Well, it's real important because we consider air to be a fluid. And since air is a fluid, we can use density as a powerful tool to see how the air is going to move around in our atmosphere.